One of the things that motivated us to develop this test system for our factory is that if you look into the typical factory environment in China today, even a better factory, a more well-disciplined factory, this is the way they do test. Very manual-driven process, very dependent on the operator to make a pass-fail judgment. And so if they have to do thousands of these things a day in a noisy, hot, and very distractive environment, just think of how many of these devices will actually slip through and go into the field that are not compliant. So this is one of the motivators for us to develop this test system. Not only are we able to improve the accuracy, but we can also improve the efficiency. And moreover, we can actually have data that gets stored and can be referenced later. Not only to be referenced later, but also to prove to our customers that these things actually gone through the test process. Our situation is so unique that we actually developed this test system ourselves. And we wrote the code and put together the pieces of instruments. And so what happens is that when an operator is going to test a batch of these power banks, what they have to do in China is that they have to begin by entering a PO number, because everything is going to be tracked by PO number. So up here, PO number, we'll just say, hit 777, okay? And then they'll hit enter settings. And then today we're going to test portable chargers, one port, among all these other different choices they can do. So we hit that button, and this environment comes up. It might be Greek to most people, but is actually quite a bit of information to help the operator to be confident that what they're testing is actually coming out right. So what they will do is that when this environment comes up, all they have to do is plug, say like a charger like this, into the socket, and the test runs by itself as soon as it detects a piece of a power bank. And so we take this thing out, plug the next one in, and you can see on the upper left-hand part of the screen the test unit number. So we're just testing number 2. We're gonna pull this one out and have no charger in here just to simulate a failure. So I will start the test here without a charger and better fail because nothing is there. Failure takes a little longer because we verify. We want to make sure that it truly is a failure, so we test it multiple times. And then we test it one more time with the charger back, so unit number 4 and number 5. At the end of this batch, what they will do is that they will hit this finish button, with the per the HIT 777 PO, and it said it was storing the information and done. But what happened really there was that this information gets stored into a file, Excel-like file like this, time-stamped, not only month, day, but all the way down to the second of when this piece was actually tested. Your pass-fail, and all the relevant parameters that made this thing a pass or a failure. And the kicker of it is this. Not only do we have this information all stored in their computer and also available in a form that's easily accessible, easily organized, but this information also just got uploaded to my cloud server right away, right when they hit that finish button. The operators in China don't even know it. So we have the information all instantly accessible. And one of the ways that we can demonstrate that is that we'll put in Doug's email here, DOUG @hitpromo.net. And if we hit a send email, and the email just got sent. So if we go and look at his tablet or his iPhone or whatever device that he has, he will receive that email with the link in that email indicating that his batch, his PO, is finished testing. As you can see, the Excel sheet that we just saw on the screen will show up on his iPad. So what happens in China will be instantly available here per your PO here with your customer.